Hello and welcome back to Blackbird. This is Venkat, and in this video, we'll be talking about control statements in Java. This is going to be a quite important video for those who are actually beginning to program in Java and might serve as a updation video for modern Java for those who are working professionals. It'll also help you out in interview preparation, so be till the end of this video in order to learn each and everything about Java. We also would like to say that we have a playlist made on Java, so you can really go and watch. The playlist link is in description. That is a complete Java playlist, so you should really give it a watch. Talking about control statements, the three type of constructs that we are going to discuss is selective, sequential, and iterative. Then we'll also talk about for each loop, some constructs which are related to DSA, and the constructs which I prefer using my own self. But before that, what are control statements? Control statements are basically blocks of code, or like some lines of code that alter the program flow based on some requirements or some condition. So, if I say that I want to accept the name of 5 users, and I only want to display those users who have their age above 21 to be to be clear of drinking and all of doing all those alcoholic activities. So in that case, you need to use control statements. You need to use if else statements in order to uh, differentiate a user whose age is below 21 and whose age is above 21. Okay, so we'll be learning about this throughout this video. So let's begin with selective statements. Now in selective examples, let's just execute the one that we talked about right now, that we want to accept a username and age, and then we need to differentiate that if that user is clear for driving or not. Okay, so what we could do is, for in order to accept a username and age, we need to have the scanner class. Once we do that, we have to instantiate. After that, we need to say that you can please enter your name. So string name is equal to dot next line. Say next, not next line. I just want the first name. And then the second thing I would say, enter your age, and it'll be int age is equal to dot next line. All right, now what I want to do is I want to check in order like if the person is above the age of 18 years or not, um, in order to confirm if he is clear for applying a driving license. So what we would write is checking here for being clear to apply for driving license. All right, so we need to tell the compiler that if the user age is greater than 18, or I should say greater than equals 18, because you can really apply after you're 18 years old. And we could print that name is clear for applying for driving license. Okay, else let's say that the person is underage, and we need to have your plus sign because we are appending a variable with a string. So let's just execute this program in order to see what would be the output. So in the place of entering your name, let's say Venkat, and when it asks for my age, I'll say I'm already 18. So you can see that Venkat is clear for applying for driving license. But if I execute this program for my younger siblings, let's say Adira, and her age is, let's say, 10. So definitely Adira is underage. So this condition here, it alters the program flow. It tells the compiler that if the user age is greater than 18, or if it is greater than equals 18, only then you have to display this particular statement, or else you have to display this one. In any case, these both of these statements won't get executed. That's for sure. This is about if else. But let's say you don't want to print anything given that the person is underage. So can we remove this else part? Yes, we can. And if we run the program, again with the same initials as of Adira and the age being 10, we won't get any kind of output here. Just because Adira was underage, her age, that is 10, is definitely less than 18. So this becomes false. All right. And after this becomes false, the statements within this won't get executed. But the compiler did not find any other statement which should have been executed if the age was less than 18. And that is why it did not print anything and it came out of the execution flow. Now let's say that there is a new rule that has been brought out where a person who is greater than or equal to the age of 16 is clear for a scooty license, and the person who is greater than or equal to the age of 18 is clear for a driving license for gearable vehicles. But somebody who is less than the age of 16 is not at all clear for any kind of license. So how we will execute that? Let us see. We could really say that, if age is greater than equals 16, then we want to check that if age is again greater than equals 18, and if it is greater than equals 18, then what I can do is I'll simply write clear for all types of licenses. But if the age is greater than equals 16 and it is less than 18, so I'll write else print that it is clear for only non-gearable vehicles. And let's say that somebody's age is not at all above 16, it's below 16, so we would simply say else want to print that it's not clear for any license. Okay, what happens here? Let's see. Let me enter some demo name and let me say it's 17 years of age. So what happens is when I enter the name Adira and the age which is 17, what the compiler does is it evaluates the conditions one by one. So the value 17 is being stored here in this variable age, which when compared again in this if condition becomes true because 17 is greater than 16. So it enters this part of the code. Now again there is a check evaluation check that if the age is greater than 18, so 17 is definitely not greater than or equal to 18, and so it prints that it is only clear for non-gearable vehicles. Now let me just show you after debugging this. So let me mark this for debugging. All right, and now let me execute this in the debug mode. Look, it asks for the name. I'll enter Adira, and the age I'll this time enter should be 18. Okay, now you can see that this scanner, there is an object that we have here for scanner class. Okay, and the buffer stores the name Adira and then the value which is 18. These are all we don't need to figure out right now. What we need to see is that the name is equals Adira and the age is 18. Now let's step into this. You see that this particular condition was true, and only then it entered here, which is age greater than equals 18, which is again true. Why? Because age is 18 and we are checking for the greater than equals sign, so 18 is definitely equal to 18, and then this particular part gets executed, that it is clear for all types of licenses. You could see that these else statements don't get executed just because this particular part of the code was executed, since the condition for this was true. Had been that it would have been false, this would have been executed. Let's again test this part of code. And let's say right now, let's say Adira's age is 15. So you can see that 15 is definitely not greater than equals 16. So the condition is right again false, and then it enters the else part, which says that it's not clear for any kind of license. That's how a nested if condition works. Now let us talk about something else. Let us say that we want to accept a username and age range, and within that range what we want to do is, let's say if the age of that particular person is between 5 years to 18 years exclusive, we want to say that the particular person is not an adult. Okay, we want to say that the person is not an adult. And given that it is 1 year to 5 years exclusive, the person is a child. Let's say if it is above 18 years, the person is an adult. And if the person is above 65 years, then the person is a senior citizen. All right. So these are a lot of conditions that we need to check for. And in order to include all of these conditions, we need to have if else ladder. What's that? Let us see here. The first condition that we talked about was if the age of the person is greater than 1, which is greater than equals 1, and age is less than is less than 5. Okay. In this case, what I would say that the person is a child. Then what we had here was that if it's from 5 to 18 years, it's not an adult, it's a teenager, let's say, just for the sake of saying. So we write else if age greater than equals 5 and age less than 18. We say that the person is young. Now the next condition, 18 years to 64, which is an adult. So again we write else if age is greater than equals 18 and the age is less than 65. We print you are an adult. And let's say it's neither of these three conditions. If the age is above 65, we'll say else system.out.println you are a senior citizen. All right. Now let us run this program in the debug mode. Okay. So firstly, we need to enter some values, I suppose. Let's enter. I will enter my name. Let's say Venkat, and then enter your age, which will be, let's say, 17. After entering this, I'll come back here. You could see that my name Venkat is being stored here. And then the age 17 is again stored here. Now here's the thing that you're going to see. In the first if condition, we see that the age is greater than equals 1. It is true because 17 is greater than 1. And what again we are checking for is whether age is less than 5 or not. 17 is not less than 5. And that is why it comes to this particular part of the code. Now in this part of the code, what we see is that 17 is greater than 5 and 17 is less than 18. So both the conditions are true and only then it'll print that I'm young. So after printing it, we get the output that I'm young. Again, if we rerun with some other age, okay, um, console, enter, and then I'll enter my name, let's say Venkat, and then I'll enter my age to be 67. All right, and I'll come back here. So it checks for the first condition, true and a false. 67 is less than 5, which is definitely false. Then again comes here that 67 is greater than 5, but it is less than 18, which is false. And it comes here 67 is greater than 18, which is true, but it's less than 65. So what it does is it executes, since none of these conditions are matching, the compiler will look for something like an else. And once it comes to this else part, it'll print that I'm a senior citizen. And there's the output. This is how if else works in Java. Let me just remove this from the debugging mode. Now let us take some other examples. Let's say that I want to accept the day number, and based on that I want to print whether that is a weekday or a weekend. But before this, what I want to do is I want to accept the day number and I want to print the day name. How exactly will I do this? I'll show you a lot of ways in order to do this. For this purpose exactly, we use switch statements in Java. So I'd remove the code from here. I'll remove this comment. Now what I need to say is enter the day number, and I'll enter choice is equals sc.nextInt. Okay. Now what I would do in order to use a switch statement, I'd write switch over the variable named choice, and we'll have a block. These curly braces denote blocks of code. So within this block of code, we'll have conditions in order to check whether the value that is stored in this variable choice, is it day one, is it day two, three, four, five, six, and whatever, and accordingly it'll print that particular day name. So we'll say that case one system.out.println, it's a Sunday, and break. Now there are two things that you see here. The first is this one, case. Switch basically uses this particular thing named as case and then followed by a label, just so ensure that the choice that we are going to have will exactly look for this particular label. So let's say if I enter the value of choice to be 1, compiler will see that where exactly in this particular switch statement is case labeled with 1, and that particular case will be executed. After getting executed, in order to ensure that no other case is executed by the switch statement beyond that particular case, we use the break statement. So break is a jump statement, to be very clear. Break is used for achieving three things. It is used to exit or terminate a switch block after some case is already executed. It is used to exit or terminate a loop, and it can also be used as a civilized form of go-to statements. We'll talk about go-to statements later. Right now, let's complete with this. Then we'll have case 2, which will say it's Monday, and then again a break statement. Let me just copy this, and now you would see that after copying this, I'm getting some kind of an error. Can we have same name or like same kind of labels, same value of labels? No, we cannot. Every label in a switch case, every condition in a switch case should be unique, because the compiler exactly and precisely checks for only those labels which are there inside of a switch case statement. And duplicates means that there would be an ambiguity within the compiler so as to what statements to execute or what case exactly to execute. So just edit this with Tuesday, Wednesday, Thursday, Friday, Saturday. Let's say that there is no label that matches all these 7 cases. What we need to do in that case, we'll have a default saying it is an invalid choice. And after default, we basically don't need to break, because this is supposedly the last statement in a switch case. Now let us execute this program and have a look at it. So let's say if I enter the day number 4, so it shows me Wednesday. If I enter the day number 7, it shows me Saturday. What if I remove these break statements? From the very start, I remove these break statements till Wednesday, till this case for Wednesday. And in the choice, I enter, let's say, 2. Look what it prints: Monday, Tuesday, and Wednesday. Why exactly? What the compiler does is it sees that choice is storing a value of 2. It comes to this case, executes the print statement, and finds there is no jump statement here after case 2. Then it comes here in case 3 and executes the print statement, prints Tuesday. Then again it finds no break statements, so it comes to case 4, and here it prints Wednesday. But after printing Wednesday, it finds a break statement here, and that is why the program flow control comes out of the switch block. right away after this statement, and henceforth there are no other cases that are executed. This condition in Java is known as fall through, where you intentionally miss out on the break statements or the jump statements so that your program executes for a number of statements given that the cases match. And this exact concept of fall through is what we are going to use for that weekday or a weekend problem. So let's program that weekday weekend problem right now. Let's say that we want to have 2, 3, 4, 5, and 6 as weekdays and 1 and 7 as weekends. So what I would do is I'll simply write case 1, then here I'll come here and I'll write case 7 and system.out.println weekend because these are Sundays, and then I'll write break. Then again I'll write for case 2, and let me just copy this, case 3, case 4, case 5, case 6, 3, 4, 5, 6, and after it we'll have a print statement s out and weekday, and then a break statement. Or again we'll have a default in order to say that it's an invalid choice. Okay, now what happens is, let's say that the value choice stores a value of 3. 3 is supposed to be a Tuesday, so the compiler matches the case here, which is case 3. It sees that there are no executable statements here. It comes down to here, case 4, no executable statements, 5, nothing. 6 finds a print statement saying weekday, and it prints weekday, and then it comes out of the execution block. So let's say I'm saying 3, so it says a weekday. But if I say 7 prints a weekend, why exactly? It's because it matches for case 7 right here. It prints the weekend, and then it breaks, comes out of the switch block. That's how fall through works. But there is something interesting that I want to talk about. Let's say instead of all these things, instead of writing these break statements, I don't want to write them. What to do in that case? What I can do is I can replace the following code in this way. I'd write case 1 comma 7, and then I'll give a lambda expression kind of thing like this, and then I'll print simply weekend. And for the same 2, 3, 4, 5, 5, 6, I'd print weekday. In that case, we cannot have default having this colon. In case of default, we also need to mention this. See how beautiful our switch statements look. This was an update which was released after JDK 10. It was there in the JEP 361. So, you can really watch and study about the design of switch expressions in JEP 361. So, if we try to execute it, let's say I'm entering the day number to be 4. It says weekday. But let's say that I'm mentioning that the day number is 1. It shows it's a weekend, but it does not print it's a weekday. Why? Because this particular thing signifies that only the cases like 1 and 7 would be executed for this switch block. And the rest of this code would be skipped. So after executing the block of code here, it'll directly come out of the switch block saying that I don't want to execute the other cases. I'm lazy. I'm a compiler. In the same way, if I say 4, I'll first check here if 1 and 7 labels match this label 4. If it doesn't, I'll come here, checks that 4 is present in these labels, and I'll execute the block of code here. In case it finds something which is greater than 7 or something which is negative, it'll come here, default, and then print the invalid choice, and then it'll end the program. This particular operator is called an arrow expression. I mean, it's an arrow operator, and the entire line 10 and 11 and 12 are arrow expressions. Let us talk about something interesting. Let's say that I don't want to print it to the console, but what I want is I want to store weekend or weekday in a string variable. Can we do that? Yes, we can. Let's say string week name is equals switch, and then here we say yield weekend, and we replace this arrow expression with a colon. The same way, here we say yield weekday semicolon. Same way we replace this arrow expression here and we say yield wrong choice. And since it's a executable statement, we need to have a semicolon at the end. Now if we try to print this week name, we'll get the name of the week. So let us run and see. Let's say I'm entering the day number to be 2, and so we get the output to be weekday, which means that switch can also act as expressions. All of these are a part of JEP 361, so you can check them out there. I'll attach a link in the description. The yield keyword, along with the colon, is used in case of switch expressions. Here, this yield keyword is basically acting like a return keyword for this particular switch expressions. So there is a difference between switch cases construct and switch expressions. Okay, but if you ask me what is recommended to use, well, definitely it is recommended to use a arrow operator because it might so happen that you will forget the break statements, and if you do so, you might introduce an unintentional fall through in your code. So what you can do is you can really have the arrow operator here and enclose the yield statement in a block like this. Okay, have a semicolon, and boom, that works. So enclosing statements in a block helps a lot, like this. The same way you can do it here. It's just the fact that these arrow operators are to be used with multiple statements, and that is why you cannot use yield keyword with just one line of statement and this arrow operator in switch expressions. So this is also something that you'll find in switch expressions JP361. You can look for it. Switch cases look for exhaustiveness. They are specifically meant for matching the exact same label, I'm repeating again, and that is why you need to have this default block. Because if the choice does not match with any of the labels in these two cases, then there needs to be a default string that you need to specify so that the variable week name has something in it or is initialized with something. So that's for switch expressions. Now let us move towards iterative constructs. Now let us talk about iterative statements. What is the meaning of iteration or looping? This means to repeat a particular statement or a group of statements for a given number of times. So, in order to repeat a statement a given number of times, or a block of statements, a block of code a given number of times, given the condition is true based on some loop condition. That is what we call as iteration or looping. Let's say that there is a block of code, you know, that all it does is it prints my name a given number of times. But how many number of times? Let's say n number of times. So initially, what we need to do in order to execute this block of statement till n number of times is we need to have a variable that will begin from 1 and will continue till n. And I'll say the compiler that, unless the value of the variable I reaches this value n, which the value which is stored in this variable n, I want to execute this block of statement on and on repeat. How exactly we will do this? Let us understand this right now in the practical part. So let me come out of the presentation mode and create a iterative examples class. Let me again enter the presentation mode. Yep, main method, usual. Now let us say that I want to execute a program where I need to print my name 10 times. Okay. For that, what I'll do is I'll declare a variable as we discussed. Int I is equals 1. Okay. Now what I'll do is I'll write while I less than equals 10, and then open a curly bracket, which means a block of statement. If this is true, this block of statement be executed, and I'll write Venkat. Okay. But if I leave it till this part, what will happen is the compiler on execution of this particular program, it'll come here, it'll see that the I is equals 1. Then it will see that while this particular condition inside of this bracket is true, I need to execute this statement, or like the block of statement of this while loop. So it sees I is 1, 1 is less than equals 10. It prints the name Venkat. It again goes here and sees that 1 is less than 10. I is storing the value 1. So it again evaluates this condition. The condition is true, and again it prints, and it goes on infinitely. Which means we need to have a condition in order to make this particular condition false. We need to do something with this variable I to make this condition false. This brings us to the four main concepts about iteration. The first is initialization. The second is condition. The third is the body of the loop. And the fourth is known as reinitialization. Now, initialization is basically a statement or a block of statements which defines the loop control variable, a variable that is responsible for controlling the loop. This is the portion that we have covered here. So this portion we term it as initialization. Okay. Condition, this is one of the most important parts of an iteration. If this condition that we put is true, only then the iteration would go to the body of the loop and this will get executed. If it is false, then no statements would be executed and the loop will break. Okay. The body of the loop contains all those statements that we need to repeat. And the reinitialization, what it does is it updates the value of the loop control variable, also known as LCV, so that conditions can also be evaluated again to check if the conditions are satisfying, and if they are, the body of the loop gets executed once again. So these four portions are really important for iteration. And within the three constructs, do while, and for loop, will study about all of this four and in what order they are present in there. So if you remember this, one initialization condition, body of the loop, and fourth is the reinitialization of LCV. Here we have done the initialization. Then here we have the condition, which is I less than equals 10. Here we have the body of the loop, but there is something which is missing here, and which is reinitialization. Okay. Now, in order to have reinitialization, you need to specify this particular thing right within the loop, so that every time the loop executes, the LCV is reinitialized to a newer value, and so that again the condition would be reevaluated at the time of execution or iteration. So here we'll say that we want to increment the value of I, which is the loop control variable, and as and when the value of I increases, I'll keep checking if the value of I is equals to 10 or not. If it is less than equals 10, then yes, the body of the loop gets executed. If it's not, then the while loop does not get executed. So let me run this program and show it to you, the output. Although the output is really simple, my name gets printed 10 times. Okay. In case of a while loop, you do the initialization first, then goes the condition, then comes the body of the loop, and then comes the reinitialization. This is for a while loop. And that is why it is also called as an entry controlled loop. Now, why is it so? It's because the condition is being evaluated before the body and the reinitialization of statements take place. So even if the condition is false, no statements are executed thereafter. If the condition is true, only then the statements are executed. And this prior check of condition before executing the body is termed as entry controlled loop. Now let's cover do while loop. In case of do while loop, everything remains the same. The only change that happens is instead of this while being present here, what we do is we write do, and then at the end of the body, we write the condition, which is while I less than equals 10, and a semicolon. Isn't it vague? It is. And so there is not much use of do while loop in programming as much as we would use for and while loops. What happens here is initialization happens for the loop control variable. The body of the loop is there, then the reinitialization happens, and then at the last the condition is evaluated. So it's like, compiler, do these stuff while the condition is true. Since compiler follows a sequential approach to execute a program, what it does is when I say that, do print Venkat 10 times, what it does is it starts printing Venkat one by one. Once it does not even care about the condition which is at the end, because it's in the lower part of the code where the compiler hasn't reached as of now. It updates the value of I, and only then it comes here to check the condition. Now, even if the condition is false in a do while loop, my body, or like the body of the loop, will get executed at least once, even if the condition is false. And that is why we call do while loop to be an exit control loop, because the condition is evaluated at the last. Now, let us talk about for loop. In case of a for loop, it is easier to do things. Here, in the very first, we have the initialization, then we have a condition, and then we have reinitialization, and then, of course, we have the body of the loop then. This is much more concise and easy to know about rather than going for while and do while loops. In case of a for loop, things remains the same just like a while loop. The change here, firstly initialization happens, then there is a semicolon, then the condition is checked, then again a semicolon, then reinitialization is present here, and within the body we have within the block of code we have the body of the loop. So first initialization happens only once this initialization statement is executed, then the condition is checked. If the condition is true, it executes the body of the loop, and then after the body of the loop has been executed, it executes the reinitialization while statement. Again, for the second run, after reinitialization has happened, it continues from here. The condition is again checked, the body executes, and then reinitialization. For the third time, condition again, body again, and then the reinitialization. This initialization section is executed exactly once. But you know what? You can really miss out on all of these parameters one by one. So there are basically three parameters that you require. First is an executable statement. Second is a condition, which is a Boolean expression. And third is again a executable statement. I'll show you some tricks on how to play with the for loop, but not right now. Let me show you what will happen if I remove this int I is equals 1 portion from here and have it here. Nothing will change. I just need to give a semicolon. Okay. Since I have already initialized it here, I don't want to initialize and give another parameter, so I can leave this parameter blank. Then I'll have a semicolon followed by a Boolean expression, and then again a semicolon and an executable expression. Okay. Now let me say that, I can really remove the reinitialization from here and I can put it here. This is also true. You can do this. No harm in it. It'll work exactly the same. Now, I want to try this out that I have all of this three and I remove the condition. I can do this as well. In this case, this for loop will continue infinitely. Look, for cannot without throwing an exception. It shows it because it's a warning. It's not an error, of course, because I'm not specifying any kind of condition right here. What if I remove all of these parameters and I just have two semicolons? Well, this is an example of an infinite for loop. Again, a variation. Let me show you something crazy. Let's say that I've done my initialization right here. So everything else remains normal, less than equals 10, I plus plus. What I do here is I write system dot out dot println. Hello, Venkat. Yo, what? Can we even write this inside of a initialization part of a for loop? Yes, we can. And now if I execute this, runs exactly fine just with this thing here. Hello, Venkat. Isn't it crazy about it? It is, right? So yeah, that is it about for loop. And I think we have covered with the control statements. That's it for this video. We have already talked about enhanced for loop in the video in which we had discussed about arrays. That's it for this video. In the next video, we'll be starting off with introduction to object-oriented programming. And I won't ask you to skip videos after that or after this one, because now the main thing starts from here. All of this was an introductory course, a very brief introductory course on Java. The main object-oriented programming principles start from here. So don't miss on this one. Thank you for watching.